Where is SpaceX in the development of Starship? Are they gearing up for Flight 6? Or are they already focusing on Flight 7? Maybe you think they're working on the orbital refueling test campaign? No. They've progressed far beyond that. While the whole world is watching SpaceX's test flights, they've been quietly developing an entirely new Starship configuration, a version with power that goes beyond anything we've ever known. Today, we're going to uncover all those secrets. SpaceX and Elon Musk have relentlessly pushed boundaries in space exploration. And proof of that ambition lies in SpaceX's plans to develop more advanced variants in the future. Do you remember Musk's presentation back in April, where he revealed some of the specs for their future Starship launch systems? Today, we're diving deep into the details of the most powerful variant, the V3. Musk mentioned that Starship V3 will feature up to 9 engines, adding 3 vacuum engines to the current configuration. With this setup, the spacecraft will boast an initial thrust of 2,600 tons, equivalent to the combined thrust of 6 vacuum engines and 3 standard Generation 3.1. This means that Starship V3 will utilize Raptor 3 engines. The slideshow also gave us a glimpse at the Super Heavy booster, which shows a massive power increase with a total thrust of 10,000 tons, equivalent to 35 times the thrust of a Raptor 3. Initially, I was skeptical about whether SpaceX would actually equip the booster with up to 35 Raptor 3. However, the Environmental Impact Statement EIS report at the Kennedy Space Center confirmed it. So, Starship Super Heavy V3 will carry a total of 44 engines, 9 for the ship and 33 for the booster, all being the latest Raptor 3. Let's take a look at the specs of the Starship Super Heavy Booster 5.3. Starting with size, Starship 5.3 stands a full 20 meters taller than Block 1, and it's easy to see why. In aerospace, every centimeter counts. This new design from SpaceX doesn't just offer more room for carrying people and cargo, it significantly increases fuel capacity. Specifically, Starship V3 can hold 1,100 more tons of fuel compared to the current version, allowing it to carry at least 100 tons more payload into orbit than Starship Block 1. This increase in upper stage weight naturally requires a stronger booster system, which is why adding 35 engines to the Super Heavy booster is a logical move. And this isn't just a design concept. While SpaceX hasn't yet fully integrated all 44 engines into one complete system, they have run extensive simulations to validate this setup. Now let's dive into the upper stage of Starship and why the addition of 3 more vacuum engines is critical. The Starship/Super Heavy system is designed with an early-stage separation strategy, meaning the upper stage has a significant role in reaching the target orbit. During this phase, Starship must continually contend with Earth's gravity, making the extra vacuum engines essential for the powerful and efficient push needed to complete orbital insertion. Adding more engines will significantly increase the thrust-to-weight ratio, TWR, of Starship. With a higher TWR, Starship can break free from Earth's gravity faster, which in turn minimizes the fuel needed to reach orbit. Vacuum engines have a higher specific impulse, ISP, compared to standard engines, meaning they use fuel more efficiently. Once the central engines complete their burn and shut down, these vacuum engines continue to operate in their optimal environment, dramatically boosting the overall efficiency of the propulsion system. From a technical standpoint, integrating 3 additional vacuum engines into the current Starship structure is entirely feasible. The existing engine bay, which was already designed to house 6 engines, has sufficient space to add 3 more vacuum ones without requiring any major structural modifications. But for the booster, it's a different story. You can't just throw in 2 extra engines and call it a day. This upgrade presents a significant engineering challenge that demands creative solutions from SpaceX's engineering team. Let's look at the current structure of the booster's engine bay. The outer ring holds 20 fixed engines, primarily responsible for generating the initial thrust to lift the rocket off the launch pad. But the real complexity lies in the inner rings of engines. These ones need the ability to gimbal or adjust their angle to control the rocket's flight path. We saw just how crucial this gimbaling capability is during the 5th flight, when the central engines had to operate at extreme angles to guide the booster safely back. With 33 engines already in place, space is incredibly tight. Each engine requires enough room to tilt up to 15 degrees when necessary. So how do you add 2 more engines without compromising this gimbaling ability? SpaceX eliminated the heat shield surrounding the engine. In previous Raptor versions 1 and 2, these shields played 2 critical roles, controlling heat transfer between engines and, crucially, containing any damage if an engine leaked or malfunctioned, keeping it from affecting the others. But with Raptor 3, the new engine generation for Starship 5.3, these shields are no longer necessary. The secret lies in the regenerative cooling technology applied to Raptor 3. This cooling tech not only dramatically reduces the heat radiated by each engine, but also allows for internalized piping, which boosts reliability and makes the overall design much more streamlined. As a result, SpaceX was able to free up enough space to add 2 more engines while still maintaining the 15-degree gimbaling ability for each inner engine. Look, in essence, this 35-engine configuration for the Super Heavy booster will look like this, and this is also how it will operate. You see, the improvements in the Raptor engines bring multiple layered benefits, creating a positive ripple effect. First off, the engine's performance specs have significantly increased while the weight of each engine has gone down. At the same time, cost and production speed have been optimized, making them much more commercially viable. But the truly brilliant aspect is how the upgrades in Raptor 3 created extra precious space in the booster's engine bay, making it possible to install these additional engines. This is rocket science, where understanding the relationship between components is crucial, because even a single technical change can have a ripple effect that impacts the entire system, whether positively or negatively. Now here's where it gets really interesting. With the configuration of 5 central engines, all 5 Raptor 3 will likely be fired during the final landing burn, the last stage of the descent. This introduces a fascinating technical challenge when considering the sheer power of the Raptor 3 engines. Each Raptor 3 engine can produce up to 280 tons of thrust. Yes, that's massive. But here's the thing. By the time the booster returns to the launch pad, most of its fuel has been spent, causing its weight to drop drastically. Essentially, the booster becomes almost like an empty cylinder at this point. Under these conditions, if the 5 Raptor engines generate more thrust than the booster's weight, meaning the thrust-to-weight ratio exceeds 1, the booster will actually lift off and start flying back up into the sky. So, the Raptor 3 engines need to be incredibly flexible when it comes to power control. These engines must operate across a wide range of power levels, from full throttle during launch to the bare minimum during landing. This flexibility requires an extremely sophisticated engine control system. In future flights, it will be fascinating to see how SpaceX manages these 5 engines during the landing phase. This is not just a test of engine technology, it's also a showcase of the precision control artistry in the aerospace industry. Being able to execute smooth landings with such a powerful engine system would be a testament to the extraordinary advancements in reusable rocket technology. It's hard to believe that Starship is still in the very early stages of its development. At the current pace of SpaceX, it might take a few more years before Starship 5-3 with the Raptor 3 engines is ready for launch. In the meantime, SpaceX will be using Starship 5-2 for upcoming Artemis missions. Based on all the information SpaceX has released so far, Starship 5-2 is only slightly taller than the Block 1 version currently being tested, with each stage potentially adding 1 more ring, and it will begin test flights early next year. This means Starship 5-3 will likely target even bolder goals. Yes, Mars. With the combined power of 35 booster engines and 9 ship engines, along with the capacity to carry over 200 tons of payload to space, Starship 5-3 will be the key vehicle bringing Mars closer to humanity.